y double dashed minus 4y dashed plus 9 equals 0, and we've got initial conditions now. Y dashed equals 0, y dash 0 equals 1, and y 0 equals 2. So let's solve this first then and get the general solution, and then we'll get the particular solution when we put in the input condition, the initial conditions. So here, the auxiliary equation then, lambda squared minus 4 lambda plus 9. Let's solve that. Lambda is equal to minus b, which is minus 4, so that makes that plus 4, plus or minus the square root of b squared is minus 4 squared, which is 16, minus 4 times a, which is 1, times c, which is 9, all over 2a, 2 lots of a, which is 1. So what have we got? We've got 4 plus or minus. Now 16, 4 9s are 36. So we've got 16 take 36 is minus 20. So I'll take the I out straight away, and it's root 20 over 2. And we can simplify that still further, can't we? Because there's a 4 as a factor in here. So we can write this as root 4 times root 5. So we've got 4 plus or minus. The root 4 we can write as 2, and the root 5 we can leave as is. And then we've got a 2 underneath, and this is lots of I. So divide by 2 and split the fraction up then. 4 over 2 is 2, plus or minus, and then 2 over 2 is 1, so we're just left with the root 5i. So complex roots, case 3 gives, and we know the formula for that now. It's y equals, I'll just show you just briefly. Here it is here. So let's use that then. A sine beta, which is, there's alpha, plus minus beta I. So a sine beta is root 5 x plus b cosine root 5 x, all times by e to the alpha, which is 2x. There we go. So now we can invoke the initial conditions. Y dash 0 is 1 and y 0 equals 2. So let's do the second initial condition that was mentioned. Y 0 equals 2 then, that gives. So when x is 0, y is 2, so 2 equals, and x is 0, so sine 0 is 0, so that goes to 0, doesn't it? And cos 0, because this will be 0, will be 1, so this will be b. E to the, so this is the only non-zero term, and it's cos 0, which is 1, and that's 1 times b is b. Expand the bracket now, it's e to the 2x, and x is 0, so that's equal to b. So read from right to left, b is equal to 2. Now we need to differentiate, so differentiating. To get y dashed. So we've got a product, we're going to need to use a product rule. Y dashed is equal to, as a product rule, u times v. So this is u, so to speak. All of that. This is v here. So, and v is a function of a function, and u is more than one term, and each term is itself a function of a function. So we have to be careful here. So what have we got then? We've got u, which is this stuff, plus b cos root 5x, u times the v dx, function of function rule, e to the something goes to e to the something, multiplied by the something differentiated, which 2x differentiates to 2. So that's u to v dx plus v, which is here, e to the 2x, times by du dx. And we're going to differentiate term by term. Sine of something goes to cos. So we've got a cos of root 5x times by the something differentiated, which will be root 5, plus, and then cos goes to minus sine, so we'll need to put a minus there, and it'll be, the root 5 will come out, it'll be minus b, cos goes to sine, and then multiplied by the something differentiated, isn't it, which is root 5. Close bracket. So that was u to v dx plus v times du dx. Sine went to cos of the something multiplied by the something differentiated, and minus b lots of cos went to minus sine multiplied by the something differentiated. There we go. So we got the initial condition to put in now. Let's go back and get it. Y dash naught equals 1. So let's put that into this part of the problem then. Y dashed naught equals 1 gives. So what have we got now then? At x equals 0, y dashed equals 1. So 1 equals. X is 0, so this will be 2. Now what's in the bracket? Sine of 0 is 0. Cos of 0, which this is 1. So this is just b. And then it's plus. And then e to the 0 will be 1. So it's just this bracket. And then sine 0 is 0. So that term can go. And we're left with a cos of 0, which is 1, times a. And then we've got a root 5, haven't we? We know b is 2 from before. So let's work out a. So that implies then a root 5 equals 1 minus 2b. And b equals 2. So it was 1 minus 2 lots of 2, which equals minus 3. So then a is equal to minus 3 over root 5. Then move the root 5 from times to divide, which is minus 3/5. Just rationalize the third by timesing by root 5 top and bottom. Minus 3/5 root 5. Minus 3/5 root 5, that's right. So we've got the answer then. So finally then, we've got our particular solution. Y is equal to a sine. Sine beta was root 5 x plus b cos root 5x times e to the alpha. Let's just go back up and get alpha. I think it was 2. There it is there. E to the, no, sorry, that's y dashed. So there it is there. There's y e to the 2x, yeah? So let's put that in. Now we need to put in our values. B was 2, wasn't it? So I'll just put in 2 there now. 2. And a, so I'm going to have to just get rid of this and move it slightly left. A was equal to minus 3/5 root 5. And that's the particular solution.